3 episodes ago, we found out a model's knowledge lives in weights, just numbers, distributed across the whole network. But that raises an obvious problem. Numbers aren't meaning by themselves. So how does a system ever turn a word like king into numbers without losing what king actually means? By the end of this video, you'll understand embeddings properly, not as a buzzword, but as a real, checkable idea. This is the episode where AI understands language, stops being magic. Once you see how meaning becomes geometry, the next several episodes, attention, transformers, how a chatbot actually reads your question, all build directly on this one idea. Forget the word embedding for a second. Just think about how you'd organize word cards on a table if similar words had to sit near each other. Here's the guess most people make, reasonably. Maybe each word just gets one number, word 1002, word 1003, like a dictionary index. Here's what's actually there instead. Each word gets a whole list of numbers, a position in a space, not an index, a location. Watch what that actually looks like. Every word becomes a point. Words with related meaning land near each other, automatically, as a consequence of training on real language. King and queen land close together. Man and woman land close together. Dog and cat land close together too, but in a completely different neighborhood, far from royalty entirely. Quick prediction. If apple and orange both land near each other, but far from king, what does that distance actually tell you? It tells you exactly one thing: similarity, as the model has learned it from real text. Near each other means the model has learned these words behave similarly in context. Far apart means it hasn't. Now for the famous demonstration, the one that convinced a lot of researchers this geometry was capturing something real. Take the point for king, subtract the point for man, add the point for woman. The result lands almost exactly on queen, not because anyone programmed that rule, but because the direction from man to woman in this space closely matches the direction from king to queen. That direction itself has meaning, roughly, something like gender, as expressed through how these particular words get used in the training text. The relationship, not just the words, got encoded as geometry. Important honest note, because this is exactly the kind of visual that misleads people. Real word embeddings use hundreds of numbers per word, not two. This flat map you're watching is a conceptual visualization, simplified down to 2 dimensions so a human can actually see it. The real space has far more room for relationships than a flat page can show. Let's break something on purpose. What happens if we only allow one number per word, the version of the myth we ruled out earlier? With one number, you can rank words, bigger number, smaller number, but you cannot express multiple independent relationships at once. King can be close to queen in royalty, or close to man in gender, but not both, not with just one number. You need enough dimensions for enough simultaneous relationships. That's the actual reason for hundreds of numbers, not showing off, capacity for many relationships at once. Here's a trickier case, on purpose. If closeness means similarity, does that mean 2 words that are close together always mean nearly the same thing? No, and this is a real limitation worth naming honestly. Words can land close together because they're synonyms, or because they simply appear in similar contexts without meaning the same thing. Hot and cold often sit closer to each other than either does to an unrelated word, because they're both temperature words used in similar sentences. Closeness captures contextual similarity, not a guarantee of matching meaning. This exact mechanism sits underneath products you already use. Search engines use it to find results that are conceptually similar to your query, not just matching keywords. Recommendation systems use it to find products or shows, like this one, by finding nearby points in the space, not by matching a category label. This is also the missing piece that makes the next several episodes possible. Once words are points in a space, you can ask genuinely new questions. Which words in a sentence should influence which other words? That question is what attention is actually built to answer, and it only makes sense once meaning is geometry. So, to recap, using the same shape as always. Problem: how can numbers represent something like meaning? Mechanism: not one number per word, a position in a high-dimensional space, learned from real text, called an embedding. Result: similar words land near each other, and relationships between words become consistent directions, like king minus man plus woman landing near queen. Limitation: closeness reflects contextual similarity, not a guarantee of matching meaning, and a real space needs hundreds of dimensions to hold many relationships simultaneously. Which leaves the next real question. Can we actually build a tiny model that learns a space like this itself, from scratch, and watch the geometry emerge? That's exactly where episode 5 goes. Quick thread check. We defined intelligence as adaptation. We opened training into parameters and loss. We found out those parameters live on as distributed weights. And today, we found out those weights can encode something as abstract as meaning, as literal geometry. Each answer keeps creating the next question. That's the format. Embeddings, vector space, similarity. You now understand how numbers actually represent meaning. Follow AllAboutAIVerse, and let's keep going, one honest idea at a time.